Alright guys, I've got a new microphone and I'm ready to go. Alright, so let's look at this thing. It says section 7.5, we're talking about special types of linear systems. Now guys, you know that with linear systems we have two or more equations, and when we graph those lines they're going to intersect and we get a point, and that point, that x and y, the coordinates, solves both of those equations. Alright, so we've been talking about that, but today we're going to talk about some other stuff. Sometimes we might have lines that when we graph them they're parallel, they have the same slope, and you guys know that the definition of parallel means that they will never intersect. Okay, and if they never intersect, that means they have no solution. Alright, now what we'll also see sometimes is that even though equations look different, when we graph them, their solutions are actually exactly the same. It's one line on top of the other. So as we simplify one equation and we compare it to the other, they look exactly alike and they have the exact same solutions. We would say that those lines coincide. They're not parallel, because remember, parallel means that they never intersect, and lines that coincide, they infinitely intersect. They have all the same points. Okay, now we can find out if lines have one solution or no solution or infinite solutions. We can find that out algebraically and graphically. Alright, now I'm going to take this system that I've got up here and I'm going to, I'm going to do it algebraically first, and I'm going to multiply this top one by -2. Okay, so now I'm going to have a new equation. I'm going to get -2x minus 6y is equal to -8. Okay, now when I draw my columns here and I add these things up, these cancel, and so do these. So I get 0 on this side, but on this side you're going to notice I get -4, and that simplifies to an equation that says 0 equals -4. That's never true. That means that these have no, what's going on there? These two equations have no common solutions. So I'd write no solution. Alright? Okay. Now, I've got that there, and if you need to look at it again, you can rewind on this, you can back it up on this video. But I'm actually going to take these out now, and I want to use this system again, and I want to check it graphically. Alright, so I'm going to change both of these lines so that they're in slope-intercept form. So I've got x plus 3y is equal to 4. I'm going to subtract x from both sides, and I get 3y is equal to -x plus 4. And then I'm going to get, divide by 3, I'm going to get y is equal to -1/3 x plus 4/3. Alright? Now, this other line, the blue line right here, I'm going to simplify that. I'm going to subtract 2x from both sides. Okay, I don't know what's going on with my board here. It's alright. Alright, I'm going to subtract 2x from both sides, and I'm going to get 6y is equal to -2x plus 4. And then I'm going to divide everything by 6, and I'm going to get y is equal to -1/3 x plus 2/3. Now guys, I'm not actually going to graph these two things. I'm going to point something out to you. This line has a slope of -1/3. This line has a slope of -1/3. Since they have the same slope, they are parallel, and I know they're parallel that they don't touch each other because they cross the y-axis. They cross the y-axis at different points. One's at 2/3 and one's at 4/3. So they're not the same line, but they have the same slope. Okay, so I know they're parallel and that they don't coincide. So if they're parallel, they're never going to intersect, and they're never going to have a common solution. Alright? So we're going to do some examples with this kind of stuff today. But remember, I talked today about special types of linear systems, but really, with linear systems, there are three possibilities. One solution, no solutions, or infinite solutions. And you can find out both algebraically and graphically. Alright, good job guys. Let's get to some examples.